All right, so now we're on page 2. Okay, so page 2, we're going to start here at the top. Okay, so you need to create the following 4 representations of the line with the slope of 2 and point -3, 4, -3, -4. Okay, so these are the 4 representations. First, you're doing a table, a graph, an equation, and then a recursive equation. Okay, explicit and recursive. All right, so first thing you want to do is note that you're given one of the points. You already know one of the points. Okay, and what I'm going to do is, okay, so -3 is one of the points. So that means it's not on this table. So that means I'm going to have to actually go backwards. So I have to go to -1, then -2, then -3. Okay, and so that means that -4 is here. All right, so now the slope is 2. So that means the common difference is also 2, which means we're adding 2. So I'm going to add 2 to -4. So plus 2, that would be -2. Plus 2, that's 0. Plus 2, that's 2. Then plus 2, plus 2, plus 2, and plus 2. Okay, that's how you complete your table. And sometimes they'll give you a point that might be right here inside the table, but if it's not, you're going to have to continue the pattern off of the table to be able to fill it in. So now I'm simply just going to graph these points. So 0, 2, 1, 4, okay, 2, 6, 3, and 8, okay, and 4 and 10. You notice 5, 12 won't fit, so that's okay. I'm just not going to put it there. But I want to continue the pattern again, exact line. So I'm going to, if I went up to right 1, okay, so I just continue the pattern. So then I go down 2 left, down 2 left, down 2 left, down 2 left, and just keep going. And I want to take a ruler and make a nice straight line. Remember, you want to connect these dots. This is a continuous equation, since it's not really talking about a sequence. Okay, it's just an equation. All right, so now write an explicit equation. Okay, so now here's when I want to use x and y in this case. So y equals, remember we're using the y equals mx plus b to make an equation. Okay, the m is our 2. That's our slope. Okay, then we're going to put x, and then plus the b. Well, I can see that in 2 different places. Well, here I know that it's wherever it touches the y-axis, so it's 2, but I also see it here at 0, 2 in the table. Okay, so plus 2. Now writing a recursive equation. Okay, so now this time I'm going to go ahead and use, and you can use whatever notation you want. You can use t of n plus 1, or f of x plus 1 is what I'm going to use in this case. But it has to, when you use a recursive equation, you have to use this x plus 1, n plus 1 format. Okay, that's important. So if I use f of x, then I have to write f of x plus 1, then I have to write f of x here. Okay, so basically, you're going to put whatever the common difference is, or the slope. So I'm adding 2. Okay, so there's your recursive equation, explicit equation. Okay, and you could write this as t of n if you'd like, or actually let's do it as f of x. I'll show you the difference. Okay, so this could be f of x equals 2x plus 2. So you can write it that way as well. It's the same thing. Okay, so now complete the table based on the recursive sequence. Okay, so notice here, that's term 1. Okay, so that goes here, so -7. There's your common difference. So I'm just going to add 5. Add 5, add 5, add 5, add 5. But I also need the 0th term, so that means I have to go back 5. So then I have to go back to -12. Okay. Now this one here says that currently the aviary has 4 birds. Well, that's month number 0. In each month, a pair of birds has 4 babies. So let's represent that with a picture. So remember, each pair has 4. So we start off at 0 with 4, and each pair is going to have 4. Okay, so then they each have 4, so for a total of 8. But I also have to include the parents in that total. So I'm going to write plus 4 because I also have to include those parents. Actually, let's just write the parent. I'm just going to draw the parents like this. Okay, so that means a total of 4 plus 4 is 8, plus another 4, 12. Okay, now I'm going to do it one more time. Okay, these two pairs are both going to have 4, so they're going to produce 8. These two pairs will also produce 4 each, so I'll draw another 8. And then these 4, again, will produce another 8. Okay, so that's 8, that's 8, that's 8. 3 times 8, 24. So now I want to take a look at the pattern. Oh, and sorry, and also I have to include the parents, okay, in that total. So now I'm going to add the 12 parents right here. Okay, so it's really, sorry, I shouldn't have wrote 24 here. So really it's 24 plus the 12 parents, which is 36. So now I'm going to check out the pattern so I can fill out the rest, because I don't want to draw all those babies anymore. So here, from get to 4 to 12, 12 to 36, I notice I'm multiplying 3. So that's a ratio. And most of these problems, again, you're going to be multiplying. So if you get the first two terms, you can find that right away. Okay, so I'm busting my calculator here and multiply these out. So 36 times 3, that's 108. Then times 3 again, 324. And then times 3 again, 972. Okay, so there's the total for that table. Okay, so now let's do we have some equations to solve. Okay, so now this one in particular here down on the left, letter A. Okay, what you want to do here is I want to get rid of these denominators. And what I want to do is find a common multiple between all these numbers. Now, I know that I want to find a number that all of these can divide into. And I know that all of these will divide into 6. So what I'm going to do is actually multiply each fraction times 6. Again, I'll show you why. So now what happens is I'm going to put them all over 1, all the 6's over 1, and multiply. So 6 times n, that's 6 over n over 1 times 2 is 2. Okay, plus, okay, 6 times 1, 6. And 1 times 6, also 6. And here, multiply the top. So 6 times 7, 42. And then 1 times 3, 3. So now what I'm going to do is just divide all these. Okay, so now 6 divided by 2, that's 3, and it turns into 3n. 6 over 6, that's just 1. And then 42 divided by 3 is 14. And if you don't know what that is, just do it in the calculator. So now I'm going to solve the equation. So I want the n by itself. So I'm going to subtract 1. Okay, so now I get 3n equals 13. And then the last step, divide by 3. That becomes a 1. And now I want to see if I can reduce that, but that's a prime number. I can't divide anything into 13, so the answer is just 13 over 3. Okay, so now this one. Okay, so now you're dealing with an expression inside of, or x inside the exponent. So what you want to do here is these numbers, the 3 and the 9, we call that the base. Whenever you have exponents, that's called the base. And in order to solve this, I need the bases to be equal. Right now it's a 3 and a 9. So what I'm going to do is rewrite them so it has the same base. Well, I know that 9 is also the same thing as 3 squared. So that's 3 squared, and the 3's are equal, okay? That must mean that x plus 1 has to be equal to 2. So basically what happens is I can just take out the 3's and write the equation as x plus 1 equals 2. Because in order for this equation to be true, that means that the exponents have to be equal. So now I just subtract 1, and x equals 1. And if you think about it, I'm going to plug it in and show you what I mean. So now if I plug this in, I'm going to plug in that 1 back into the equation to check. So I plugged in the 1 for x. And now 1 plus 1 is 2. And we know that 3 squared is 9. So you know that it's right. Okay. So now this one over here. Okay, so here what I want to do is get x by itself. So on this side, I want to move that 7 to the right. So I have to add it to the like term. So now that cancels or becomes 0. And then the x terms I want on the left, so I'm going to take this x term and move it over here by subtracting